we're now going to look at the approximate solutions to trigonometric equations. Now these are significantly more complicated because there are a lot more moving parts, especially when we're doing it in radians. And so the ideas you want to keep in mind are the unit circle diagram and reference angles. Those will guide you through the rest of the calculation. So we'll start off with sine of theta equals 2/3. Now what we did before is we had a chart of values here and we just sort of looked up the value and to get on the chart to get the reference angle. That's not going to work for us anymore. So what can we do? Well, the first thing we're going to do is we're going to ask our calculators to give us the inverse sine of 2/3. And we're going to do this first one in degrees. And so when you do that, you will get 41.81 degrees. Okay, so the question is, well, what does this value mean? It's not good enough to just say, well, I plugged into the calculator and gave me a number. We need to think about this in the context of solving equations like this. So let's go to the unit circle picture. So in the unit circle picture, we're looking for sine is equal to 2/3. Sine of the angle is equal to 2/3. Sine corresponds to the y direction. So we want the y to be positive 2/3. And so we're looking at a solution in the first and the second quadrant. This value, 41.81 degrees. Well, it's pretty clear that that's going to be this one right here. Notice that this is going to be the reference angle, right? So it's an angle measured against the x-axis. And so to get the angle in the second quadrant, we're going to do the same thing we did previously, except now with this crazy angle as opposed to one of the known angles. This angle right here is 41.81 degrees. What does that tell us about the angle we care about, the actual solution angle? So the solution angle is going to be this guy right there. Well, if we think about the picture, that's going to be 180 minus 41.81. So we do 180 degrees minus 41.81 degrees, and that gives us 138.19 degrees. Right, so the solutions, theta, we have two solutions, just as we did before. We've got a 41.81 degree solution, and then we've got a 138.19 degree solution. Now in this problem, it wasn't specified to find solutions only on the interval from 0 to 360 degrees, so we have to get all the angles. We did this with radians, and to do it with degrees, it's the same concept, except instead of adding 2 pi k, since we're in degrees, we have to do this in degrees. And so this is going to be plus 360 degrees times k, plus 360 degrees times k, where k is an integer. So what happened? Well, remember, we started off with this equation. We can use the unit circle picture, and then when we plug this value into the calculator, this tells us one part of the diagram. From that part of the diagram, we use reflections and reference angles to figure out how we can get a different measure for the second angle. This will get more complicated when you have negative values, and we'll look at an example of that next. So here's another example. Cosine of theta is equal to negative 0.4. Now once again, this is not a known value from our unit circle chart, so we're going to have to do this the long way. And in this case, we're going to do it in radians. So what is our picture? We have our unit circle. We have cosine, which is the x-coordinate. We want the x-coordinate to be negative 0.4. And so we see we have a solution in the second quadrant and a solution in the third quadrant. What do we do now? Well, now we go to our calculator. We calculate the inverse cosine of negative 0.4. And we're going to do it in radians, and this is going to get us 1.9823. 1.9823. What does this number mean? How do we understand and interpret this number? Well, there are a couple ways of looking at it, and probably the clearest one is to think about the inverse cosine function itself. What was the what was the range of the inverse cosine function? The inverse cosine function gave us a value from 0 to pi. This number right here, if it's going to be one of these angles from 0 to pi, that's a solution. It's got to be this one, 1.9823. The importance for drawing this picture is that you cannot assume that this is the reference angle. A lot of students will take this value and then add it to pi or subtract it from 2 pi or whatever they think they're trying to do with it. And it's really not immediately clear that that's the right thing to do. You have to just think through the picture. So the question now becomes, how do we get the rest of this? There are two ways of going forward. One way is reflecting this whole thing, and the other way is to look at the reference angles. I'm going to look at the reference angles because I think it's the more important skill. So the reference angle for this diagram is right there, or excuse me, for this angle is right there. Question is, what is that angle? Well, the whole thing is pi, and this side takes up 1.9823 of it, so that other part is whatever's left over after you subtract it off from pi. So we have to do pi minus 1.9823. And again, that comes from looking at the picture. This is not some general formula that you always use. It comes from looking at this picture and thinking about it. And so in this case, since we're using decimals, we're going to use 3.1416 as our approximation to pi. This is 3.14159. That 59 rounds up to the 0.6. Since we have 4 decimals here, we'll use 4 decimals here. And we plug that in. We are getting 1.1593. This value is the reference angle, 1.1593. We want this angle in the third quadrant. What's that going to be? Well, it's going to be pi plus the reference angle, right? Because the reference angle, if you reflect downward, will get you this one. So this 1.1593 is the same as this. That's also 1.1593. And so the solutions that we get, when we get the value straight out of the calculator, 1.9823, the third quadrant angle is going to be pi plus the reference angle, pi plus 1.1593. If you plug that into a calculator, 1.9823, that one of course hasn't changed, and this one turns out to be 4.3009. You do not have a lot of experience with decimal values and thinking about radians and things like that at this point. And this is actually where some of that begins, because at some level, this picture here is kind of hinting you, it's pushing you in a certain direction to think about things in a certain way. 1.19823 is between pi over 2 and pi. If you use decimals there, pi is 3.14, pi over 2 is 1.57, so you can sort of tell that that's in between those two. And so you can use those quick values to sort of work your way around this picture and think about it a little bit more. But here's a full calculation for how we would get the solutions to this equation in radians.